Okay, Assalamu alaikum students. So today we are going to do O-level physics, May June 2025, paper 4, variant 2, 1 hour का paper है. This is basically ATP का paper. A student investigates the refraction. Okay, so let's start with question number 1. A student investigates the refraction of a ray of light passing through a transparent block and determine the refractive index n of the block. The student's ray the student's rate ray sheet is shown full size in figure 1.1. ठीक है. So a student is investigating the refraction of a light and determine the refractive index of the block. The outline of the transparent block is shown by the rectangle ABCD. Okay, so this is the rectangle ABCD. Okay. A line SR that meets the side AD of the block is also marked. Okay, this is the line SR that meets the side AD of the block. Okay. On figure 1.1, draw a normal to the block at point R. Extend your normal 6 centimeter above AD and below side BC. Okay. So label the point where the normal crosses BC of the block with the letter T. Measure the angle theta between SR and the normal. Okay. So you have to draw the normal. Let's draw the normal. Okay, let's draw the normal like this. A normal is a 90-degree line on the transparent block. A normal is a 90-degree line to the barrier, to the block, whatever you want to say. This is the normal. The point where the normal passes BC, बेटा वो पॉइंट जहां पे नॉर्मल BC को पास कर रहा है, that is represented with a letter T. You can represent it with a letter T here. Okay. And you have to measure the angle between the normal and SR. This angle theta turns out to be what? 30 degrees. Simple. You can write it here. This angle theta, I have already measured it using a protractor, comes out to be 30 degree. बेटा ये angle किस तरह measure करोगे आप? How will you measure this angle? You will keep the protractor here in the middle and measure this angle. That comes out to be 30 degree. Simple. Let's further move ahead. The student positions an illuminated slit on the rate ray sheet so that a ray of light passes along the line SR towards that. Mark with a small cross as X 2 points on the ray that leave the side BC of the block. It removes the transparent block. ठीक है. तो आप बेसिकली क्या कर रहे हो, आपने एक रे ऑफ लाइट यहाँ पे प्लेस किया along the line SR. This passes and produces a refracted ray outside of BC. तो बेसिकली यहाँ पे अगर आपने रे ऑफ लाइट प्लेस की है तो उसकी रिफ्रैक्शन यहाँ पे आउटसाइड पे आ रही है. यू हैव मार्क 2 क्रॉसेस. ओके, नाउ लेट्स फर्दर मूव अहेड. क्या लिखा हुआ है? ऑन फिगर 1.1 ड्रॉ अ लाइन थ्रू द टू क्रॉसेस टू मीट BC ऑफ द ब्लॉक. अच्छा जी, आपने एक लाइन बनानी है थ्रू द टू क्रॉसेस टू मीट द लाइन BC ऑफ द ब्लॉक. How will you do that? You will do somewhat like this. इस तरह आपने लाइन बना दी. Yeah, somewhat like this. Let's erase the top region like this. ठीक है. तो let's also make sure that this is tilted correctly. इस तरह से and like this. Perfect. ठीक है. Label the point where this line meets side BC with letter E. अच्छा, ये लाइन जहां पे BC को मीट कर रही है, label this with E. This is E. Okay. And label the other end of the line as F. ठीक है, ये आपने F label कर दिया. Okay. Draw a straight line from point E to point R. अच्छा, E और R कौन से हैं भाई? This is point E, this is point R. Let's draw a line between point E and R. Let's choose a different color. Yeah. Let's draw a straight line between point E and R like this. Perfect. What else do we have, bhai? Acha, measure the length A of the line ET on figure 1.1. Acha ji. आपने लाइन ई टी की मेजरमेंट निकालनी है. विच लाइन? दिस लाइन. ओके, दिस इज लेबल्ड एज ए. बेटा ये लाइन ई टी इज लेबल्ड एज ए और इसकी मेजरमेंट क्या आ रही है? 2.3 सेंटीमीटर्स. देन यू हैव टू मेजर द लेंथ ऑफ लाइन ई आर. अच्छा जी, ई आर कौन सी लाइन है? दिस वन. दिस वन इज योर लाइन ई आर. दिस इज लेबल्ड एज बी. इसको आपने स्केल से मेजर कर लेना है. This comes out to be 6.4 centimeter. Let's also write it down. This comes out to be 6.4 centimeter. Perfect. On figure 1.1, extend the line FE into the block until it meets the line RT. अच्छा जी, आपको line FE को extend करना है. So take this line and extend it like this until it meets the point or the line RT. Okay. लेबल द पॉइंट वेयर एफ ई मीट्स आर टी विद द लेटर जी. अच्छा जी, जहां पे एफ ई और आर टी मीट कर रहे हैं, लेबल दिस एज योर पॉइंट जी. लेबल दिस एज योर पॉइंट जी. ओके, व्हाट एल्स डू वी हैव टू फाइंड? मेजर द लेंथ ई जी ऑन फिगर 1.1. ओके, व्हाट इज ई जी? भाई ई जी ये वाली लेंथ है. लेट्स मार्क इट विद अ डिफरेंट कलर. लेट्स से ग्रीन प्रॉब्ली. ये आपकी लेंथ ई जी है. If you measure it with a ruler, this comes out to be roughly C, that is 4.5 centimeter. ये क्या आ गई? 4.5 centimeter आ गई. You can write it here. Simple. Let's further move ahead. Use your value of C part 1, C part 2 to calculate the refractive index of block 1. How will you calculate the refractive index of block 1? B divided by 2A. B की value क्या है बेटा? What is the value of B? 6.4. Okay. Divided by 2a. 2 multiplied by the value of a. What is the value of a? 2.3. Okay. What is the answer here? Answer निकालो बेटा, क्या आता है? Calculate the answer. 6.4 divided by 2 into 2.3. This comes out to be 1.4. Simple. Use your answer from C part 2 and D to calculate a value for the refractive index N2 of the block. How will we calculate the refractive index N2 of the block? B की value क्या है भाई? 6.4. Okay. What is the value of C? C की value is 4.5. Divide कर दो. What does this comes out to be? 6.4 divided by 4.5. This is equals to 1.42. Perfect. Two quantities are considered to be same within the limits of experimental accuracy if their values are within 10% of each other. Okay. बेटा जब भी आपने एक्सपेरिमेंटल एक्यूरेसी वेरीफाई करनी होगी, there is a very simple rule that you will follow. Compare your value of N1 for the refractive index calculated in E part 1 with the value of N2 calculated in E part 2. You state whether the two values can be considered same. अच्छा जी, जब भी आपने एक्सपेरिमेंटल एक्यूरेसी निकालनी होगी, यू विल डू टू थिंग्स. द लार्जर वैल्यू minus the smaller value divided by n average multiplied by 100. If this value comes less than 10%, then both the values are same. बेटा अगर आपका percentage difference comes out to be less than 10%, then both the values are same. अगर percentage difference 10% से ज़्यादा आता है, then both the values are different. Okay. So what is the larger value of n here? 1.42. What is the smaller value? 1.4. Okay. 1.42 minus 1.4. What is the average value of n? n average किस तरह निकालते हैं? n large plus n small divided by 2. What is the large value of n? 1.42. Small value of n, 1.4 divided by 2. This comes out to be 1.41. 1.41 into 100. ये कितना परसेंट आ जाता है? 1.42 minus 1.4 divided by 1.41 into 100. that is equal to 1.4%. Your percentage difference between the two value is 1.4%. Okay, 1.4% is the percentage difference between the two values. Okay, now what will you say? Since the percentage difference is less than what? Is less than 10%, both the values are considered to be same. You can write this here. First of all, let's minimize everything here. You will say, यहाँ पे रख लो calculation को. You will say since percentage difference is less than 10%, both values are same. Simple. Let's further move ahead. One source of inaccuracy in this experiment is careless measurement. State another source of inaccuracy in this experiment. Okay, what could be another source of inaccuracy in this experiment? Beta, it might be difficult to place the crosses accurately. ये जो आपने यहाँ पे crosses place किए हैं, ये वाला और ये वाला, it might be difficult to place the crosses accurately. Simple. It might be difficult to place the crosses accurately. Simple as that. Nothing complicated here. आगे बढ़ा जाए. चलो, let's move ahead. A student investigates the resistance of a thermistor at different temperatures. The student constructs the circuit shown in figure 2.1. अच्छा जी, ये circuit show हो गया. The thermistor in figure 2.1 is placed in an empty beaker and is at room temperature. Okay, now you are at the room temperature. The student measures the room temperature. The thermometer is shown in figure 2.2. Record the room temperature on the answer line. You have to record the room temperature on the answer line. This is what? 21 degree centigrade. Simple. आगे बढ़ते हैं बेटा. Let's move ahead. The student closes the switch, records the potential difference across the thermistor, while the thermistor is at room temperature QR in the top row of table 2.1. He opens the switch. The voltmeter is shown in figure 2.3. Okay. Record the potential difference Vxy while the thermistor is at room temperature QR in table 2.1. Okay, you have to record this potential difference. This comes out to be what? 3.1. You can write it here. The potential difference comes out to be 3.1. The student disconnects the voltmeter from point X and Y, reconnects the voltmeter across the 220 ohm resistor between point Y and Z, closes the switch, records the potential difference across the 220 ohm resistor voltage YZ while the thermistor is at room temperature in the top row shown in table 2.1. Okay. Redraw the circuit shown in figure 2.1 on page 5 to show the voltmeter connected to measure the potential difference across the 220 ohm resistor. Okay. So you have to redraw the circuit, but this time you have to place the voltmeter across the 220 ohm resistor. How will you do that? Easy peasy, lemon squeezy. You will say, first of all, you have a power supply, positive, negative. Okay. Then you have a thermistor. Okay. Then you have a 220 ohm resistor. And the voltmeter is placed in parallel to this resistor. Voltmeter क्या किया हुआ है बेटा? Parallel to this resistor place किया हुआ है, and you can make a switch here as well like this. Okay, you can make a switch here like this. ठीक है, चलो, let's move ahead. Let's move further. The student pours some hot water into the beaker containing the thermistor, places the thermometer into hot water and stirs the water gently. He waits for 30 seconds, measures the temperature QH of the hot water, measures new value of voltage potential difference Vxy and Vyz while the thermistor is at the temperature of the hot water. Temperature of the hot water is 83 degrees centigrade. Okay. The students' measurements are recorded in the bottom row of table 2.1. Okay, so the measurements are recorded in the bottom row here. Okay. Explain why the student waits for 30 seconds before measuring the temperature of the hot water. बेटा हॉट वाटर का टेम्परेचर मेजर करने से पहले स्टूडेंट 30 seconds वेट क्यों करता है? Why is the student waiting 30 seconds before measuring the temperature of the hot water? This wait of 30 seconds allow the thermometric liquid to expand. या आप ये कह सकते हो this wait of 30 seconds allows the thermometer to adjust to the temperature conditions. So you can say here the 30-second wait. The 30 seconds wait allows the thermometer to adjust to the surrounding temperature. To the surrounding temperature. Simple. Let's further move ahead. Explain why the student stirs the water before reading the temperature of the hot water from the thermometer. बेटा हमने बताना है why the student stirs the water. The student जो है वो water को हिलाता क्यों है before measuring the temperature. To ensure uniform distribution. To ensure uniform distribution of heat. To ensure uniform distribution of heat among water. Simple. Simple as that. Nothing complicated here. आगे बढ़ते हैं. Examine the data in table 2.1. Okay. Compare the reading for the potential difference Vxy at room temperature with the reading for the potential difference Vxy at the temperature of the hot water QH. Okay. बेटा हमने voltage across the thermistor की reading at room temperature देखी, that is 3.1 volts. When the temperature increases in hot water, the voltage across the thermistor is 1.2. The voltage has decreased. Okay. Suggest what causes the difference in readings. You will say as temperature increases, the resistance of thermistor. क्या होता है resistance of thermistor? Decreases. Hence, voltage across thermistor decreases. Simple. Nothing complicated here. The current in the circuit is calculated using this equation, okay, where R is equals to 220 ohm. Use the measurements recorded in table 2.1 to calculate the current at the room temperature and the current at the hot water. Okay. So you have to calculate the current. Current किस तरह निकालेंगे बेटा? You will take voltage YZ divided by 220 ohm. 1.4 divided by 220 ohm. Current क्या आ जाएगा? Let's do that. 1.4 divided by 220. This comes out to be 0.0064. Correct to 0064. ये आ गया आपका टू सिग्निफिकेंट फिगर्स पे आंसर. इसको भी कर लो. 3.3 divided by 22 ohms divided by 22 ohms. This comes out to be 0.015. Okay, correct to two significant figures. You can write both the answers. Let's further move ahead. The resistance of the thermistor is calculated using this equation. Okay. Use data in table 2.1 on page 6 to determine the resistance at the room temperature and the resistance at a hot water. Okay, how will you do that? At room temperature, आप resistance किस तरह determine करोगे? At room temperature, voltage Vx divided by the current. Voltage Vx क्या है room temperature पे? Let's go above. Voltage Vx at room temperature is 3.1. The current is 0.0064. So you can write 3.1 divided by 0.0064. क्या आंसर आता है? Let's calculate that. 3.1 divided by 0064. This comes out to be 480 ohms. Correct to two significant figures. This is 480 ohms. अब आप हॉट वाटर पे भी देख लो क्या टेम्परेचर आएगा, वोल्टेज एक्स वाई डिवाइडेड बाय द करंट। बेटा हॉट वाटर में वोल्टेज क्या है आपका एक्स वाई, व्हाट इज द वोल्टेज एक्स वाई इन हॉट वाटर 1.2 divided by the current 0.015, 1.2 divided by 0.015, 1.2 divided by 0.015, what does your answer comes out to be? निकालो जरा ये आंसर क्या आता है। This comes out to be 80 ohms as your total resistance here. Perfect. अब आगे आ जाओ। अच्छा जी, लेट्स सी दिस। क्या लिखा हुआ है? द average change in resistance of the thermistor per degree Celsius for the thermistor as the temperature of the thermistor rises from room temperature to the temperature of hot water. Okay. Use the equation to calculate alpha. अच्छा जी, हमने alpha निकालना है। What is the change in resistance? Resistance के अंदर क्या change है? You are going from 480 to 80. Resistance में change क्या है? 480 minus 80, रेजिस्टेंस में क्या चेंज आ गया? 400 का। व्हाट इज द चेंज इन टेम्परेचर? हाँ जी, चेंज इन टेम्परेचर क्या है? कैन यू सी द हाईएस्ट टेम्परेचर इज 83, द इनिशियल और द लोएस्ट टेम्परेचर वाज व्हाट? इधर आ जाओ, 21। ओके, 83 माइनस 21, व्हाट इज द चेंज इन टेम्परेचर? 83 माइनस 21, चेंज इन रेजिस्टेंस क्या हो गई? 480 माइनस 80, 400 divided by 83 minus 21. This gives you a value of 6.5 ohms per degree centigrade. Easy peasy lemon squeezy, कोई मुश्किल वाली बात यहाँ पे नहीं है। Let's further move ahead to the next question. Okay, what is written here? इसको थोड़ा सा zoom out किया जाए बच्चों। अच्छा, a student investigates the stretching of a spring. Okay. The student suspends the spring from the clamp of a retort stand as shown in figure 3.1. अच्छा जी, आप clamp से spring को suspend कर रहे हो। This is a retort stand. Okay. The student takes the reading from the meter rule to determine the length of the spring. Okay. On figure 3.2, take the reading from the meter rule, level with the top of the spring and level with the bottom of the spring. Do not include the loops at the top and bottom of the spring in your measurement. Record your values correct to the nearest 0.1 centimeter. Okay. First of all, if you realize top पे क्या reading आ रही है? 39. What is the reading with the top of the spring? 39 centimeter. What is the reading with the bottom of the spring? 41.1 centimeter. Simple. Let's further move ahead. Draw on figure 3.2 to show how the student uses a set square to take the reading from the meter rule with the bottom of the spring. अच्छा जी, बेटा यहाँ पे आप सेट स्क्वायर किस तरह यूज कर सकते हो? Somewhat like this, to make sure that the reading is perfectly aligned with the meter rule. Let's further move ahead. Calculate the length L of the coiled part of the spring. Use the equation shown. Okay. You have to calculate the length L. How will you do that? क्या आपके पास बॉटम पार्ट की रीडिंग है? यस, 41.1। टॉप पार्ट की रीडिंग है 39। दिस कम्स आउट टू बी 2.1 सेंटीमीटर। लेट्स इरेज दिस। अच्छा जी, आपके पास क्या रीडिंग आ जाएगी? 2.1 सेंटीमीटर एज योर लेंथ। ओके, वी हैव रिकॉर्डेड दिस लेंथ इन द टेबल। ठीक है, हमने ये लेंथ को टेबल में रिकॉर्ड कर दिया है। सिंपल एज दैट, नथिंग कॉम्प्लिकेटेड हियर। Record L in table 3.1 on figure on page 12 for a load. ठीक है, हम ये कर देते हैं। This comes out to be 2.1 centimeter. Simple. आगे आते हैं। The student places a load of 1 Newton on the spring. Okay. Takes reading to determine the new length of the spring. Okay. The top of the spring does not move, but the bottom of the spring move downward. The student determines that the new reading on the meter rule with the bottom of the spring is 45.2. Okay. Calculate the new length of the spring. How will you calculate the new length of the spring? 45.2 minus 39 is equals to what? 45.2 minus 39 is equals to 6.2 centimeter. 6.2 centimeter is the length when the load is 1 Newton. यहाँ पे आपने लिख दिया. Simple. The student repeats the procedure in B part 2 for loads L is equals to 2 Newton, L is equals to 3 Newton, 4 Newton, 5 Newton. The results are shown in table 3.1. Okay. On the grid provided in figure 3.3 on page 13, plot a graph of length on the y-axis against L on the x-axis. अच्छा जी, आपने लेंथ कहाँ प्लॉट करनी है? Y-axis पे. Okay, so mark it. Length slash centimeter on the y-axis and load slash Newton on the x-axis. Simple. ये कर दिया हमने. Okay. Yeah, we had to do this. Start the graph from the origin 0, 0. Draw the line of best fit. Okay जी. आपने 0, 0 से ऑलरेडी स्टार्ट किया हुआ है. परफेक्ट. यू हैव टू ड्रॉ द लाइन ऑफ बेस्ट. अब थोड़ा सा सोचेंगे, गौर करेंगे. ऑल्दो आई हैव शोन दिस मल्टीपल टाइम्स ऑन दिस चैनल, बट लेट्स डू इट अगेन. फर्स्ट ऑफ ऑल सर, हाउ टू कैलकुलेट द स्केल ऑन द वाई एक्सिस. वाई एक्सिस पे स्केल किस तरह निकाले? व्हाट इज द मिनिमम वैल्यू ऑफ वाई? मिनिमम वैल्यू ऑफ वाई 0. What is the maximum value of y? 21.9. What are the number of large boxes on y? This is the first large box. Now, what do I mean by large box? One large box is equals to 10 small boxes. One large box is equals to 10 small boxes. Always remember that. Y axis पे कितने large boxes हैं? 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11. Okay. Y axis पे कितने large boxes हो गए? Large boxes is equals to 11. Can you calculate the scale for the y axis? Yes. Y maximum minus y minimum divided by the number of large boxes. Y maximum क्या है भाई? 21.9 minus minimum, that is 0, 11. What does this comes out to be? 21.9 divided by 11. This comes out to be 1.99. This is equals to 2. That means that each large box on the y-axis will represent 2. So after one large box, we can write 2. After another large box, we can write an increment of 2. This becomes 4. बेटा एक और लार्ज बॉक्स के बाद आपने फिर से +2 कर देना है. This will become 6. After another large box, another +2, this becomes 8. After another large box, क्या करेंगे? After another large box, you will add further +2. This will become what? 10. After another large box +2, this becomes 12. After another large box +2, this becomes 14. After another large box +2, this becomes 16. After another large box +2, this becomes 18. This becomes 20. This is 22. Now you will do the same thing when you are calculating the scale of the x-axis. X-axis का जब scale calculate करोगे, same काम करना है, कोई difficult काम नहीं. Okay. What is the minimum value of x? हाँ जी. X की minimum value क्या? Okay, I think it is getting congested here. क्या करें इसको हम थोड़ा सा यहाँ पे करके रख देते हैं राइट साइड पे, सो दैट यू नो कि हमने यहाँ पे क्या किया. ओके, सो व्हाट इज द मिनिमम वैल्यू ऑफ एक्स? हाँ जी, मिनिमम वैल्यू ऑफ एक्स क्या है भाई? एक्स की मिनिमम वैल्यू इज 0. व्हाट इज द मैक्सिमम वैल्यू ऑफ एक्स? 5. व्हाट आर द नंबर ऑफ लार्ज बॉक्सेस ऑन एक्स? ये 1 हो गया, ये 2 हो गया, 3, 4, 5, 6, 7 and 8. I think there are a total of 8 large boxes. Yeah. On the x-axis, तो divide कर दो. Divide it by the number of large boxes. That is 8. यहाँ पे लिख लेते हैं फर्स्ट ऑफ ऑल तो ना, जूम इन करके। नंबर ऑफ लार्ज बॉक्सेस कितने भाई? व्हाट आर द लार्ज बॉक्सेस? Large boxes are equal to 8. Can you calculate the x scale? Yes. X maximum minus x minimum divided by the number of large boxes. X maximum की वैल्यू क्या है भाई? 5. X minimum की वैल्यू क्या है? 0 divided by the number of large boxes, that is 8. Can you calculate x की scale? हाँ जी, 5 divided by 8, x की scale is 0.625. Now obviously you wouldn't be plotting 0.625, because हमेशा याद रखो that the scale that we plot should either be in the multiples of 1, 2, 5 or 10. हमेशा जो भी आप स्केल प्लॉट करोगे that should be in the multiples of 1, 2, 5 और 10. ओके, हमेशा हमेशा जो भी आपने स्केल प्लॉट करना है बच्चे, वो कौन से मल्टीपल्स में होगा? 1, 2, 5 और 10. यहाँ पे आपका स्केल क्या आ रहा है? 0.625. यू कैन नॉट प्लॉट 0.625. You will round this upward. You will plot a scale of 1. Scale of 1 से सर आपका क्या मतलब है? If you're starting at 0, after one large box, this will become 1. Other large box, this will become 2. The other large box, this will become 3. This will become 4. This will become 5. This will become 6. This will become 7. This will become 8. नाउ अगर आपने स्केल सही से प्लॉट कर लिया है, आपने एक्सेसेस सही से मार्क कर लिए। एक्सेसेस मार्क करने का मतलब क्या होता है सर? लेबल करना है कि एक्स एक्सेस पे यू आर प्लॉटिंग एल स्लैश न्यूटन, एंड ऑन द वाई एक्सेस यू आर प्लॉटिंग स्मॉल एल स्लैश सेंटीमीटर। अगर आपने ये दो काम कर लिए, यू आर इजिली गेनिंग 2 मार्क्स आउट ऑफ द 4 ग्राफिकल मार्क्स। ओके, यहाँ तक बात ले रहे सबको? ओके, वाई हैज द स्केल शिफ्टेड? I don't know. I think I will have to write this again. ये 2, 4, 6, 8 वाली स्केल थोड़ी सी शिफ्ट हो गई है, आई डोंट नो व्हाई। ओके, लेट्स राइट इट अगेन। इसमें तो कोई मसले वाली बात है ही नहीं, वापस लिख लेते हैं, ठीक है? चलो, 0, 2, 4, 6, 8. Okay, what else? After 8 you will have 10. Okay, 12. Then you have 14. Then you have 16, 18, 20, and then you have 22. चलो, अब बस पॉइंट प्लॉट करते जाओ बेटा, सिर्फ और सिर्फ पॉइंट प्लॉट करते जाओ, लाइफ को एंजॉय करते जाओ। फर्स्ट पॉइंट क्या है? एक्स एक्सिस में 0, वाई एक्सिस में 2.1। ओके, फर्स्ट पॉइंट में आपकी लेंथ लोड 0 है, और वाई एक्सिस में यू हैव अ लेंथ ऑफ 2.1। हाउ विल यू प्लॉट 2.1 हियर? है, ये क्या हो रहा है यार? वाई आर द मार्किंग्स गेटिंग disturbed when I plot them? I don't know. When the length is, when the load is 0, अच्छा जी, जब आपका लोड 0 है तो आपकी लेंथ क्या हो गई? 2.1. Somewhere here this becomes your first point. Okay. When your load is 1 Newton, your length is 6.2. Okay, you can write that as well. When your load is 1 Newton, आपकी लेंथ क्या हो रही है? 6.2. Somewhere here. Okay. I'm trying my level best to mark the points, but for some reason, the points are moving forward and backwards. At a load of 2 Newton, your length is 10. 2 Newton पे आपकी लेंथ क्या हो गई? 10 हो गई इधर। Perfect. At a load of 3 Newton, your length is 14. अच्छा, 3 पे आपकी लेंथ क्या हो गई? 14, somewhere here. Perfect. At a load of 4 Newton, your length is 18.2. Load of 4 Newton पे आपकी लेंथ क्या है? 18.2. Somewhere here. Okay, what else? At a load of 5 Newton, your length is 21.9. Somewhere here. Now you can plot the line of best fit. थोड़ा सा zoom out करते हैं। I hope. ओहो, ये पॉइंट्स एक तो अजीब हो जाते हैं। Why does this happen? मुझे नहीं पता why is this happening, लेकिन पॉइंट सारे फ्लक्चुएट कर रहे हैं, वाई? आई थिंक आई विल हैव टू मार्क द, हाँ मुझे, मेरा ख्याल है ऐसे ही मार्क करना पड़ेगा। चलो, now I will have to draw the line like this because I don't know why for some reason the points are fluctuating when I zoom in or zoom out. So let's mark the line. We have to draw the line of best fit like this. Line of best fit is a line that passes through maximum points. Let's try to make this pass through the maximum points. Okay, okay, okay. Yeah, it is passing through the maximum points. ठीक है, एक लाइन ऑफ बेस्ट फिट हमने बना दी, दैट इज पासिंग थ्रू द मैक्सिमम पॉइंट, सिंपल। या दैट्स करेक्ट। लेट्स फर्दर मूव, ओह we have some parts left here, okay। Use your data in table 3.1 and the graph in 3.3, okay, to determine the extension of the spring when a load of 3.5 न्यूटन is applied to the spring। अच्छा जी, जब आपने लोड लगाया है 3.5 न्यूटन का, that is the load is somewhere here, ठीक है, लोड ये आ गया 3.5 न्यूटन का। When you are applying a load of 3.5 Newton, what is the length? The length is approximately, that is 16। ठीक है, जब आपने 3.5 न्यूटन का लोड लगाया है, द टोटल लेंथ इज 16 सेंटीमीटर, बट यू हैव टू कैलकुलेट द एक्सटेंशन। What was the length when no load was applied? 2.1 सेंटीमीटर। सर आपको ये कहाँ से पता चला? ये लिखा हुआ है, जब कोई भी लोड अप्लाई नहीं था तो लेंथ 2.1 सेंटीमीटर थी। एक्सटेंशन क्या हो जाएगी? एल टी माइनस एल नॉट, 16 माइनस 2.1, दैट इज 13.9 सेंटीमीटर इज इक्वल टू योर एक्सटेंशन। इससे आसान सवाल बेटा वो आपको क्या दे, वो फिर अब आपको यही कर सकता है कि फ्री के मार्क्स बांट दे। ठीक है, इससे आसान और क्या सवाल होगा? A student suggests that the stretch length L of the spring is proportional to the load capital L. State if the data in table 3.1 supports this suggestion. Justify your answer using the data in table 3.1 or the graph in figure 3.3। बेटा देखो, अगर आपकी फोर्स डबल हो रही है, फोर्स 1 से 2 न्यूटन जा रही है, क्या आपकी स्ट्रेच लेंथ डबल हो रही है? 6.2 से 12.4 पे जा रही है? नहीं। If the force is doubling, the stretch length is not doubling. That's why stretch length and force are not directly proportional. So you will say, no, they are not proportional। और रीजनिंग क्या दोगे? नो दे आर नॉट प्रोपोर्शनल, रीजनिंग क्या दोगे? as the load as the, भाई क्या हो रहा है? why is this happening? Okay, you will say as the load doubles. I will investigate my one note after this lecture. As the load doubles, the length of the spring does not double, does not double. Hence, they are not directly proportional. Hence, they are not proportional. Simple. Let's further move ahead. आगे बढ़ा जाए। Line of sight parallax errors can occur when readings are taken from the meter rule. Okay. State one practical technique other than using a set square that ensures accurate readings are taken from a meter rule। एक प्रैक्टिकल चीज आप क्या कर सकते हो? मेक श्योर योर लाइन ऑफ साइट इज perpendicular to the meter rule। मेक श्योर दैट योर लाइन ऑफ साइट is perpendicular to the meter rule, perpendicular to the meter rule। Simple, nothing complicated here। The student repeats the procedure described in C 2 more times and averages the readings before calculating the spring lengths for each load L। Explain why the student does this। averaging reduces random errors. हमेशा जब भी आप एवरेज लेते हो आपके रैंडम एरर्स रिड्यूस हो जाते हैं. लेट्स फर्दर मूव अहेड, आगे बढ़ा जाए. अच्छा जी, लेट्स सी दिस क्वेश्चन. ओके. As a metal ball falls through a liquid, it experiences a frictional force from the liquid that opposes the motion of the metal ball. Okay. Plan an experiment to determine the relationship between the density of a liquid contained in a measuring cylinder. Okay. You have to determine the relationship between the density of a liquid and the average speed of a metal ball falling through the liquid. The average speed of the ball is calculated using this equation: distance traveled divided by the time taken. The arrangement of the apparatus is shown in figure 4.1. तो बेसिकली हो क्या रहा है बच्चों, आप डिफरेंट डिफरेंट डेंसिटी के लिक्विड्स यूज कर रहे हो एंड यू आर नोटिंग डाउन द एवरेज स्पीड ऑफ द मेटल बॉल टू फॉल थ्रू दोस लिक्विड्स. ओके. The experiment is simple, not that difficult. Let's further see. The apparatus available includes what? A measuring cylinder, a metal ball, a selection of different liquids whose densities are known. Okay. You may also use other apparatus commonly found in a school laboratory. In your plan, include any other apparatus needed. Beta, first of all, you will need a meter rule. एक मीटर रूल क्यों चाहिए होगा? To measure the height from which the ball is fallen. एक मीटर रूल क्यों चाहिए होगा बेटा? To measure the height from which the ball is fallen. ठीक है, वो हाइट मेजर करनी है जिससे बॉल फॉल करेगी. दैट विल रिक्वायर अ मीटर rule like this. This is your I. Okay. So you will say that a meter rule meter rule is required to measure the height to measure the height from which the ball falls. Secondly, आपको क्या चाहिए होगा यहाँ पे? You will need a stopwatch. You will need a stopwatch to measure the time taken for the ball to fall. या फिर लिख लो, use a stopwatch to measure the time taken for the ball to fall. ठीक है, ये दो इंस्ट्रूमेंट्स हमें चाहिए होंगे. Okay, what is the next point? Okay. A brief description of the methods, including what you will measure and how will you make sure that your measurements are accurate. अच्छा, क्या मेथड हम लगाएंगे यहाँ पे? You will release the ball from rest. आपने बॉल को रिलीज करना है from rest from a height h of the liquid. ठीक है, drop the ball from rest and measure the height of the liquid from which you are dropping the ball. Measure the time taken to reach the bottom. फिर लिख दो, drop the ball from rest and measure the height h from which it falls. Note down the time taken for the ball to reach the bottom. Apply average speed is equals to distance over time to calculate speed. To calculate speed. What will be your last key point in this? ये जो bullet point है उसमें हम last चीज क्या लिख लेते? Repeat the experiment for liquids with different densities. बेटा हमेशा हमेशा जब भी आपने ब्रीफ डिस्क्रिप्शन ऑफ एक्सपेरिमेंट लिखनी है तो आपने लास्ट पॉइंट क्या लिखना होता है? यू हैव टू टेल दैट यू विल रिपीट द एक्सपेरिमेंट, तो लिख दो यहाँ पे रिपीट द एक्सपेरिमेंट, द एक्सपेरिमेंट फॉर liquids with different densities, for liquids with different densities. Okay, अच्छा जी, और क्या की पॉइंट है? What is the next key point? What are the variables that you will control? कौन से variables control करोगे? The volume of water that you use every time and the shape and mass of the ball. You will say volume of liquid and mass of ball should be kept constant. Should be kept constant. Okay. Fifth key point क्या है बेटा? The result table to record your measurements. अच्छा जी, टेबल में measurements record किस तरह करोगे? You will say, you will say, you will say. एक टेबल बना लो इस तरह का. You will say the density slash और डेंसिटी के क्या यूनिट्स होते हैं? kg m-3. Then you will say height slash meters. Then you will say time slash seconds. Then you will say speed slash ms-1. तो आपने टेबल भी दे दिया. टेबल में सारी की सारी मेजर्ड वैल्यूज आती हैं, हमेशा याद रखना. ओके, व्हाट एल्स? लास्ट चीज क्या है? आई थिंक वी हैव टू स्टेट हाँ. हाउ विल यू प्रोसेस योर रिजल्ट्स टू ड्रॉ अ कंक्लूजन? व्हाट विल यू से? ड्रॉ अ ग्राफ. ड्रॉ अ ग्राफ ऑफ डेंसिटी against speed. Draw a graph of, yeah, plot a graph of density, plot a graph of density against speed and check for a relationship. Check for a relationship. Simple. Nothing complicated here. This marks the end of paper 4 variant 2. ठीक है. And O level physics May June 2025. If you have any questions you can ask right away.